Welcome to day 2 of rational and irrational numbers. I took this picture while I was student teaching in England, and this is one of my most favorite parts on the places on the planet. This vine up here is a wisteria vine in this hall that just smelled amazing the entire way down. A little bit of information here. Since 7 squared is 49, and negative 7 squared, so negative 7 times negative 7, is also 49. 7 and negative 7 are called the square roots of 49. So we're going to be examining some square roots and cubed roots today. This symbol right here is called the radical symbol or the square root symbol. When we look at taking the square root of something, for example, the square root of 64, we think, what number times itself is 64? Well, 8 times 8 is 64. Here we're looking at what number times itself is 100, but this negative sign out front is going to come to the answer and make the answer negative. So think of it as the opposite of the square root of 100. Well, 150 times 2 is 100, but that's not a number times itself. But 10 times 10 is 100. So the negative square root of 100 is negative 10. Here I've got plus or minus 100. That plus or minus again is going to translate over to the answer. And I've got what number times itself is 100? Again, that's 10. So for this one, there's two answers, positive 10 and negative 10, which you can write as plus or minus 10 or just as 10 comma negative 10. For example 4, this square root is around the whole fraction, but you can think of it as being the square root of the numerator over the square root of the denominator. So in this case, we have the square root of 4 over the square root of 25. What number times itself is 4? That'd be 2. And what number times itself is 25? Well, that's 5. So the square root of 4 25ths is going to equal 2 fifths. Now you'll notice there was no number on either of these two problems on this page or the two problems on the previous page. But here I've got a 3 up at the top. So that means instead of the square root, we're going to be looking at the cubed root. So I'm thinking what number times itself equals 8. Well, let's see, 1 times 1 times 1 is still 1. 2 times 2 is 4. 4 times 2 is 8. So this is the cubed root of 8 is 2, because 2 times 2 times 2 is 8. Try this. Take the negative square root of 16 and the square root of 1/16. Pause your video and give it a try. Did you get negative 4 and 1/4? If you did, give yourself a giant all caps yes with a couple exclamation points there. If you didn't, give yourself an X, go back and figure out your mistake. When you find your mistake, put your circle around your X and move on. A perfect square, another definition for you. A perfect square is a number that has integer square roots. For example, 1, 4, 9, 16, 25. That comes from 1 squared. 1 times 1 is 1. 2 squared. Well, 2 times 2 is 4. 9, that's 3 squared. 3 times 3 is 9. 16 is 4 times 4, or 4 squared. 5 squared is 25, so on and so forth. So these are perfect squares because you're squaring a number. We also have perfect cubes, and that's a number that has an integer cube root. So 1 cubed, 1 times 1 times 1 is still 1. 2 times 2 is 4. 4 times another 2 is 8, so 2 cubed is 8. 3 cubed, 3 times 3 is 9. 9 times 3 is 27. So each of these are the numbers cubed. You try. List the first 20 perfect squares and the first 10 perfect cubes. I would recommend putting this in chart form, maybe listing 1 through 20 across, and then start putting your, you can label this as the squares. And so then you'll have the 1, 4, 9, 16, and then you can have another row that has the cubes. And 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, just like what we had on the previous page. I'm not going to show the entire chart, but we will talk about this in class tomorrow. So pause your video and complete your chart. Irrational numbers. We've talked about rational numbers. Rational numbers are kind of your pretty numbers. Irrational numbers are gross. They're non-repeating and non-terminating decimals. So one example of that is pi. Pi is 3.1415926535897932338. It's just like somebody vomited numbers after the decimal point. The same thing's going to be true when you have the square roots of non-perfect squares. It's going to have this big giant gross decimal at the end. It never stops and it never repeats. So it would be really gross to write it. So far, they found enough digits of pi that it could be typed on a strip of paper and reach from the earth to the moon and back, and they still haven't found an end, and they still haven't found any spot where it repeats. The same is true for numbers that are not perfect squares. For example, the square root of 5, if you type that in a calculator, it comes out to be something gross. It's 2.2360679 and then it's going to keep going and going and going. We've yet to find an end to it, and we've yet to find a repeating point. Your turn. List 3 irrational numbers that have not already been listed. Again, there's infinitely many of these, so I'm not going to give you the correct answer because there's infinitely many answers. Homework assignment. You've got 4 problems. Make sure you are giving a valid attempt on each of these, and we will talk about them tomorrow. Have a great day.